good afternoon from here anyway. And I guess it is afternoon there as well. We all three of us are thrilled to be able to share with you our program. There's other agents on this team as well, and Mark and Emily and I will represent the entire team and talk mostly about the Petioles SAP testing program, but sort of maybe a little bit more generic in terms of some of our water and nutrient programs that we would have that are important in this particular area. All right. The first thing is that I've known Aparna for a while when she was in grad school. So Aparna, this is greetings to you from your old blue dye days here at our research center, and it's a thrill to be able to see you as you've moved forward in your career. And the acronym that was back in the Aparna Gazula days, the blue dye don't lie. So I'll be talking a little bit more about that, but this is a really interesting method for us to be able to help growers to be able to visualize where the water goes and therefore where the water goes. I mean, where the fertilizer goes. The topic here for today is going to be specific on using petiole sap testing in Florida. And we're going to be focusing on how we do it as an extension group, but I'm going to start with a little bit of background on how the science ties into this. And so there's a lot of science that has been put into the standards for which we try to target, in other words, the acceptable ranges of petiole sap nitrogen and petiole sap potassium, and that's what we're trying to monitor. So it has been a great way to get us onto farms and to try to help farmers not only on water and nutrient management but other topics as well. Just a little bit of background here about this region. The Suwannee Valley area is the area around where the Suwannee River, which comes out of Georgia and goes out to the Gulf of Mexico, that's the region that we all are working in. And this is, in my mind, one of the last main agricultural areas where we have diversified agriculture and lots of family farms in this particular region. There are other large areas of agriculture in Florida. For instance, the sugarcane area down in the Everglades is a massive acreage situation, but not as diversified as the crops that we have up in this area. So we have deep sandy soils, very environmentally sensitive area, and mainly because we have these environmentally sensitive waterways, either rivers or springs, and there's actually more freshwater springs in this region of than any other place in the world. So we've got lots of first magnitude springs here that are important to recreation. It all ties together underneath us in the Floridan aquifer. So we have this deep sandy overlay over top of the Floridan aquifer. So the aquifer itself is very vulnerable because of this karst topography and sandy soils on which we are farming. This is just one of the pictures of small springs that comes out and works its way down some tributary in the region. But this is very typical of the waterways that we have, and sort of begins to visualize the vulnerability of this water as it comes out of the Floridan aquifer. A few BMPs to sort of set the stage here. We are becoming in a much more increasingly regulatory environment for our farming. And I know this is not new to you all in California. So I think we can sympathize a little bit with the kinds of regulatory aspects that you have in California. But water and fertilizer are two aspects here that are becoming increasingly regulatory. So our practices, we're trying to teach the 4Rs. It's all about nitrogen here where we are. If you go to other parts of the state, either east or south, it's probably more about phosphorus than it is nitrogen. But this presentation today is going to be related to nitrogen and how we're using petiole sap testing to try to help our farmers to fulfill the regulatory requirements. But the 4Rs, the right rate, the right source, the right placement, and the right timing, in this case of nitrogen. A lot of us feel like really need to add a fifth R, and that's the irrigation. And so here, if we can manage the irrigation, we got a chance at reducing or making more efficient inputs of nitrogen fertilizer. If we can't change and do a better job on irrigation, in many cases, we can't really do much to change things if we're leaching a lot of the nitrogen down through the sandy soils. So the monitoring part with petiole sap testing is immediate, and it helps us to be able to get information right away. We don't have to worry about sending samples off. And it does help us to meet this IFAS nutrient rate requirement that now the University of Florida's nutrient rates for a specific crop, for instance, 150 pounds per acre for watermelons, is actually the regulatory aspect of watermelons and nitrogen. It didn't used to be that way. It was simply the recommendation or suggestion from the University of Florida, but now they've converted that into what they are actually monitoring from a regulatory standpoint. As I mentioned, there's a lot of research that has gone into this. A lot of this was done back in the mid to late 80s and then on up through the 1990s. And if you search for this kind of information, petiole sap testing guidelines for nitrogen and potassium, typically you're going to see whoever has that resource material, you're going to typically see that it's the University of Florida's information, because it is sort of the gold standard of the guidelines in terms of petiole sap testing. And then to give full credit, I have a brother, George, is retired now from the University of Florida. And back in those days, he was the leader in developing the research programs to identify what the acceptable levels of these nutrients should be. And I started down here in the late 80s and began to work with him on some of these research trials, and have updated some of them myself as we've continued on to this. But it is based on replicated scientific trials, so that the numbers that we see are coming from that publishable data set for both nitrogen and potassium. The research trial setup might look something like this, where we can have a little plumbing system on the left-hand side, and you see there that there's actually 8 different ports. So we could run a trial with 8 different nitrogen rates, for instance, in watermelons. And then we could go in and do the petiole sap testing anywhere from 0 up to, say, 200 or 250 pounds of nitrogen. And we would take the yields from those plots and then cross-reference the parts per million of nitrogen and or potassium that optimize the yield, and at what petiole sap test result is that yield optimized. So it is very scientifically based to be able to come up with what those numbers are and how they are represented. So this is what it might look like. We would have maybe a typical growth curve here, where we start out with a little bit of pre-plant fertilizer and then start with small injections, 1 pound per acre per day of nitrogen. And then that would increase to 1.5 to 2.5. And then as the crop begins to mature and ready for harvest, we typically will level that off. And so that's kind of the way that we would typically gear those research trials. And this is very representative of what we would typically see on farms as well. So not only do we start out with the replicated trials on this, but I think for Emily and Mark and I, we are constantly getting lots and lots of samples from farms. And if there's something unusual that happens, we're able to take that information back and then relook or reevaluate, maybe come up with some new research protocol to see if there's something different that is going on. So this is what we would typically do with all of those plots. And you might have, the 8 plots or the 8 treatments times 4 plots. You might end up with 30 some individual samples. We would take them back to the lab, and we would separate them in half, and half of them would go to an agricultural lab for the dry leaf analysis as a standard comparison to our petiole sap testing. And so we would set it up in the lab like this and run all of the samples on our petiole sap testing meters. And this is what that would typically look like. We would pull the leaf blade off of the petiole. So when you pull a watermelon leaf, we're taking the most recently matured leaf, just like you would if you were going to send it off for a dry leaf analysis. And then we would remove the petiole from the leaf blade. And we would want to do that immediately so that the leaf blade itself does not pull water from the petiole. Once you remove the blade from the petiole, the sap in the petiole is going to be more stable and consistent. If you leave the blade on there and you leave it in an area where it could start pulling sap from the petiole, then sometimes you can get some erroneous results. But anyway, we handle all of that in the same exact fashion. And I just use an example here to kind of finish out my part of this in the beginning, that we knew that something was different when seedless watermelons came on the market. Excuse me. Because the seedless petiole sap tended to be lower than what we were used to in seeded watermelons. And so we set up a research trial to try to verify what we thought we were seeing in the field. And early in the season, you can see here that the sap nitrogen on the top of this table, potassium on the bottom part of the table, that for nitrogen sap early, before we started getting fruit load, there was no significant difference in petiole sap nitrogen. But as the crop began to set and it began to pull or set fruit and pull differently in terms of the seedless versus seeded fruit, we did begin to see this drop in the acceptable range for petiole sap testing for seeded versus seedless. And it was significantly different between those two. So we had to create an update to our petiole sap testing document that would indicate that the seedless varieties are going to give you a different range. And so I just make a point here, because Emily's going to be mentioning this a little bit later, that if you were to try to push the seedless at the upper rates where we were normally used to with seeded watermelons, I'm going to say you may not ever be able to get there without some incredibly high nitrogen rate. So we know now that the seedless are just normally going to have a lower concentration of petiole sap nitrogen. However, if you look down at the bottom, the potassium does not change. So there was no significant difference across the entire season for whether or not the potassium was coming from seeded or seedless cultivars. So the summary here, the dry leaf analysis was similar for both nitrogen and potassium in both seedless and seeded. And that worried us a little bit because what we were seeing in the field with the petiole sap testing was different than that. So I think that one of the things where I feel like the petiole sap testing might be an advantage is that apparently it's a little bit more sensitive than the regular dry leaf analysis would be, which means that we can sense and see differences more quickly in petiole sap testing. And certainly the petiole nitrogen was lower in the seedless than the seeded. Typically, once you get into the middle part of the season, typically was about 20% lower than the seeded cultivars after the first fruit are set and enlarging. So the lower numbers that we were seeing in seedless, then it makes sense, and now we would just consider that to be a normal deal. Here in Florida, and I think it's similar in California, is that the majority of our acreage is seedless. So when we go into a field, we're basically testing seedless varieties. There's a little bit of seeded watermelon that's used as a pollinizer source, but typically the majority of any field here in the area of Florida where we are located is going to be a seedless variety primarily. So we went back to our publication and we were able to provide this update and just continue to be able to move that information forward as we go. And so this is a link to the publication here at the University of Florida for petiole sap testing. It's got all of the research that's been done. You'll notice, for instance, in cucumbers, we've got really good numbers for nitrogen, but there has not been a calibration for potassium, for instance. But for a crop like eggplant, we've got both nitrogen and potassium that are incorporated in. And that document shows a little bit about what we're talking about, what plant part it is that we need to take. Is it the petiole on a simple leaf or a compound leaf? And so that information is available there on that document as well. That's the main go-to place for this information. But we have found that that we get very similar results whether we're using conventional or controlled release fertilizer kinds of applications. So it's been a very dependable source of information for us as we've worked our way through the season. And I put this slide in here because you can see at the very end when the farmer started injecting conventional nitrogen sources that the red line went up, and we were able to determine that very quickly and very accurately with petiole sap testing and in the terms of nitrogen for this particular farm. The green dotted line that goes up and down is where the fertigations first started. So you can kind of see that rise in the petiole sap testing information. So with that, I'm going to turn it over to Emily Beach, and Emily's going to tell you a little bit about the kind of equipment that you would need. The first part of it sort of being the research basis, but now we're going to turn it to how are we doing this here in our extension programs. Emily?
Emily, you're muted.
Sorry. Thank y'all for having us today, and thank you for everybody for joining in and listening to the talk today. So yeah, my part's just going to be mainly, how to utilize this actually in the field, and then for people who are, doing this for farmers or farmers yourself, we want to, kind of give you the opportunity to look at how we set this up and then how you can carry this on. So you can see, I mean, obviously the most important part of this is having the meters. And so I think the meters, were somewhere around $400 or $500. So it is a little bit of an expense to get this started, but I can't say enough how important it is to have this as a real-time opportunity to measure those levels, there in the field. And like Bob said, with sending the dry tissue off, that is an opportunity that you have, but that's a timely measure that you have to take into account there. This just gives you the opportunity to look at it, in real time and make those adjustments as you need to. So just kind of going through and just thinking about, the materials that you would need. I've got a list here on the slide that, everybody can read, but having the calibrating solution that goes along with the meters is very important to be able to reset those each time whenever you get ready to start the testing. A cutting board is always very handy to have on hand to be able to get the petioles cut up in such a way that it'll fit into your garlic press, which also is very important. If you'll notice here, the garlic press that we have in this picture, I will just give everybody a note here that's from experience. I've bought several different garlic presses before I actually found this one that Bob uses, and it has the little spikes. You can see the little black spikes there, and it just really helps whenever to get all the discard out. So if you use a regular garlic press that doesn't have the little spikes that'll go into the holes, and you have to dig out the petioles every time. So that's just a little, trick of the trade there. And so, scissors or a knife, either one, distilled water to be able to rinse out the meters every single time whenever you're using them in between, so that you're not getting a skewed calculation there. And then of course, we write everything down on a piece of paper. Some people may be a little bit more advanced in terms of entering it into a computer or putting notes in your phone, either way, but we kind of like to be able to watch that progress. And Mark's going to talk about what he does with the paper, after he leaves the field, which is a really neat setup there. So these are just some things to have on hand. Whenever I first started an extension and I started doing this, Bob gave me the opportunity to follow him around to watch as he went through that first season. And Bob actually carries all of his stuff in just a like a Black & Decker toolbox. And so I did the same exact thing. You know, it's got the little shelves on it. So it's just a thing that you can stick in your vehicle and have there, you know, all the things inside of it that you need. So those are just the materials that you would need to be able to get started on the Petioles sap testing. And then Bob, we can move to the next slide. Just, you know, the methods that we use to be able to do this. So I just showed the picture that you've seen before on the slide, that just has, you know, you're going to take the recently matured leaf, you're going to cut the petioles from that, and then making sure, you know, that you remove it from the blade. And so then you're just left with the petioles to be able to have that real-time calculation there. And so then you'll cut it up even smaller. So our guys typically will take the petioles from the field and then bring them to us. You know, if you're in the field, I think Mark does somewhere he goes directly into the field, or, you know, if I'm in the field and they want to take a real-time reading at that moment, you know, then we'll just do it there in the truck. But put it in those little Ziploc bags and label them. That's always very important to know where each one of them came from. And then, you know, once you get to where you're going to cut them up, you can see the bottom picture. That's just me in my office doing that on a day. So just cut the petioles up and stick them into the garlic press. And so the calibration of the meter sometimes can be a little bit tricky, but honestly, after you read the directions, you know, and do it a few times, you'll kind of be able to troubleshoot that as it goes, whenever there are issues, and you'll be able to recognize that fairly easily. So the meters are very friendly, in terms of user, you know, abilities. And so, and then what we do is we just, you know, write those down. So if my producers are there with me, then we'll kind of talk through it. Or, you know, I'll sap test everything at one time and then send them the numbers, and then, you know, we'll talk about it from there. But I always just have the chart that shows where they should be, where the level should be in terms of the growth stage, and then be able to use that as a comparison each time we take the sap. And so, you know, just kind of piggybacking off of what Bob said, you know, you do have the ability to use the dry leaf analysis, including that entire petiole, and sending that off. But, you know, again, the amount of time that it takes to send it off and then get it back is, you know, it takes a lot longer to be able to do that, instead of just being able to have that real time to make those adjustments, immediately after you get those results. So, you know, in speaking about that, I have done that too, you know, send it off for people, and then it might be, you know, several days or a week afterwards. Whereas with taking the petiole sap test, you know, then they can make the adjustments that they need to at the next irrigation event, or, you know, the next day, whatever comes first. And so, you know, that to me, that just really allows for being able to have a response, for whatever way you need it. If you need to increase the nitrogen or lower it, either way, but that gives you the opportunity to do that. So obviously what we're talking about here is using the fresh, the testing from the petiole. Always going to go with their most recently matured leaf, and that's, you know, across a lot of crops. But if you ever have any questions about where that is, you know, the easiest thing to do is just start at the end. But, you know, there's, I think in the guide that Aparna shared, it does have directions about that too. But you can always reach out to us if you have any questions on that. So just to kind of, I think this is my last slide, just to end things up for us. You know, in terms of extension agents, I know that California is a little bit different, but once you've done this a few times and you get used to doing that opportunity that you have to see where your plants are at, you know, that status at the present moment, it really does make a difference, in being able to make those adjustments that you need for your production. And, so we do, you know, it a lot here, and it is a little bit intimidating in the beginning, I will say. You know, I was very worried about kind of going off on my own and being able to do that. But once you get used to it, it just seems like, you know, it's a very easy process once you get going. Oh, sorry, I do have 2 more slides. So this was something that Bob kind of talked about earlier, and we've seen this, you know, in the field. This is actually one of our producers that we have. He bought his own testing kit, and now he does his sap test, you know, by himself. He'll call every now and again, into Bob to see, you know, where his level should be, or how he needs to make adjustments. So you can see these are his numbers. So What you see in the graph there, the blue being the nitrogen upper limit and then the green, the lower limit. And you can see as the season progresses, you know, sometimes he's right above or below the line, but then as he goes on, he's right where he needs to be in terms of what the status of his nitrogen should be at the given planting time that he's at. So, you know, we've seen a lot of success with that, with them being able to track those numbers. Just to kind of hit home the last point that Bob was making earlier, you know, we do see these all over the place, especially whenever you go to farms that manage things differently and manage their irrigation differently, which Bob mentioned earlier is a very important thing. You know, you can measure your fertilizer and it have it timed out, but the irrigation really does also make a big difference in the way that all of this works. But just if you look at these numbers, so just for these purposes, you know, we've labeled them farmers 1 through 6, and you can see where their nitrogen levels were at first harvest. So it should be between 6 and 800 parts per million. And you can see some of them were a little bit below that, and then some of them were way above that. And the ones that were way above that, interestingly enough, didn't meet the yield that the ones with the numbers that were on target. So the yields really do have a direct correlation to the numbers that the research has proven to be where they need to be. So, you know, I visit people all the time that, you know, feel like the higher numbers are going to be better. But in the long run, what we've seen is that the correlation that is here is definitely true, and it works, and that the yields, you know, follow themselves as they need to with going with the recommendations.
Thanks, Emily. And we're going to transition next to Mark. And I think just the final comment on the last slide is that you can tell when you got a really heavy fruit load, and when you got a heavy fruit load, it'll pull those nitrogen levels down, and that's sort of the other piece of that. So thank you, Emily, for how you're making that work in your county. And I'm going to go to another county extension agent now, Mark Warren. Mark, if you want to tell us your story.
All right. Well, like the others, I very much appreciate the opportunity to be here and to speak with y'all. I'm going to kind of take it just from our county and how we're managing in our county. And I will say, before I even get going, I'm very fortunate in our county that our county funds a program assistant that makes this possible. What we do here, if it wasn't for that program assistant, we would not be able to accomplish. So we're doing quite a few farms, and that's kind of what I'm going to talk to you about how we're maintaining some of that data and what we're getting out of it. So first thing is that we've started, and you'll see a couple of other surveys mentioned in here, but this is a survey that we send out to our local producers to start with, just to find out who's interested in what resources. So we get the farmer name, the field name, we try to get a pin to the field location. So we're using Survey 123, which is I'm not sure if you're familiar with it, but it's an ArcGIS tool that we can put a survey together. We send it out via a Remind app to our producers. And basically on their phone, they can just click a few of these fields. I just put a kind of a screenshot up here of what this looks like to them. But they can put in their name, their field name. They can go on a map and drop a pin to the field. They'll tell us how many planted acres they have, what varieties they're growing, just some other information, planting dates. But then down at the bottom of it, it asks them what services would they like to receive from Extension. And right now, there's only a couple, but weekly petiole sap testing would be one of those. And then we started doing something we call a flush calibration. I'll tell you more a little bit about that as we get going. But anyhow, we send this survey out. The farmers that are interested reply back, and automatically this information populates into this next screen, which is go ahead, Bob, which is a spreadsheet that we have. And I've covered up the producers' names there, but anyhow, you can see it has the field listed, the varieties, acreages that they have planted at each field. Emily had spoke to you about the ranges of nutrients, so we've kind of got that keyed up at the top. In our county, we kind of have 3 different growing regions across the county, with Chiefland being one of those, and then Bronson would be another, and Williston would be another. And so on each day, we're testing a different region of the county. And so my program assistant goes out on Tuesday and tests Chiefland, and then out on Wednesday and tests Bronson, and on Thursday tests the Williston area, because we have so many fields we're testing. But anyhow, as you look across this screen and you see planting date, and then the next columns beyond that are what their weekly analysis was for each field. And so obviously a lot of our farmers have multiple fields and they're listed here. And we have some of that background information. We try to document what growth stage they're in at the point we test them. I don't have a pointer, so I can't point at what I'm talking about. But anyhow, so if they're not quite mature enough to test, there's a blank space there. And then as they go through their different growth stages, we'll document that and record what the readings are. So the way we're doing this logistically, and as Emily had mentioned, we do some of these tests at the edge of the field, but we're now at the point where we're testing so many fields that's just not very efficient. Emily mentioned calibrating these instruments, and basically every time the instrument shuts off, I recalibrate it. So if you're going from field to field to field, you spend as much time recalibrating as you do anything. We've got to the point now that, like Emily, we collect the samples, we put them in a cooler on ice. As Bob mentioned, we have removed the leaf blade and just have the petioles, Ziploc bags. We've also started using a tackle box out of a clear tackle box that we can actually has compartments in it so we can separate them. It just makes them easier to maintain. Throw them in a cooler of ice in the back of the truck just to keep them chilled, and then bring them back to the office and process the samples in the heat of the day in the afternoon. I know it doesn't get hot in California, but in Florida in April, May, you really don't want to be out in the field at 3 o'clock in the afternoon trying to sample plants. And in all honesty, and Bob, I don't know if you mentioned this much, but I saw one of the questions come up about sensitivity of time of day when we're doing these samples. So the closer we can hit to this 10 to 2 mark as far as collecting the samples, we feel like that's the best time to be gathering. This goes back to some of the research that Bob and his brother did. So we try to collect those samples then and then come back and process them in the afternoon. Go ahead, Bob. So as I mentioned, so we're doing about 50 plus fields. I think we're actually last year, I think we were close to 56 fields we're testing weekly. That's about 65% of our planted acreage in Levy County. As Emily mentioned, some of our producers are doing their own, not many, but a couple are. We also have some crop consultants that are doing some additional acres in the area. So there's more than just this 65% that are being affected by the use of this technology. We're typically running 6 to 8 tests in the season, probably more often closer to the 6. I think as you saw on one of Bob's slides, I mean, we're waiting until these vines are at least coming off the plastic a little bit. So they're 10, 12 inches before we're able to get that most recently mature leaf. And we'll do weekly tests up to the point where they start harvesting. Once they start harvesting, we kind of stop. It gets hard at that point to find the right leaves to collect anyway. As Bob mentioned, we try to really focus on the seedless melons. And I don't know, once there's a lot of abuse in there with the harvest crews, it just gets tougher and tougher to find the right plants. And with all practicality, they're locking in their nitrogen application for the remainder of the season at that point anyway. They're not adjusting it much. But anyhow, so we do 6 to 8 tests a season. We get these results. My program assistant sends me the results in the afternoon, and then immediately we'll text those out to the producers. Like Emily, we'll send it out with a range of where they ought to be, that sufficiency range. If there are any dramatic outliers, and there are on occasion, we'll just, for whatever reason, something just doesn't test right. I typically go back to those fields the following day and I'll retest those with my equipment at the edge of the field. If it holds up, or anytime we have an extreme, a high or a low, especially as you can see on that little graph, there was quite a period there that they were below where they should have been, and that's a county average. But anyhow, I'll call the producers and we'll start talking about what might be going on. So one of the things, I think Bob mentioned this too, this is a great tool, a great resource to help our farmers. It's also a great foot in the door to go in and start having conversations about fertilizer and management and options and irrigation management. It just opens the door for a lot of other conversations. I have, excuse me, found out that every farmer speaks a different language when you start talking to them about fertilizer. When you ask them a question, you're low or you're high, what did you do last week? Well, I pumped 150 gallons. Well, 150 gallons of what? and on how many acres and how often are you doing that a week? I found that you really have to ask a lot of questions and recognize that those farmers are going to package that up in different ways that you're going to need to be able to sort through. I'd love for everybody to say, well, I'm injecting 1.5 pounds of nitrogen per acre per day, but I don't think I've ever gotten that response when I've asked a farmer where they're at that point in the season. Thinking about reasons for extremes, why we might be seeing, high or low. I also saw a question pop up on the bottom about timing. And timing relative to when the last injection was made and when we're going in and actually pulling the sample. We're pretty confident that, in a 22 to 26 hour after an injection, we see kind of peak levels mapping out. But if I had a producer that for whatever reason was injecting late in the afternoon and we're in there early the next morning collecting the sample, it might be a reason why that reading would be a little low. A lot of times we'll go back and retest that to see if we see a response the next day. And most times we do. Also thinking about overcast days or cool weather when plants may slow down, you might see some differences. But again, this is just opening up a door for conversations. I think it has built great relationships with our farmers. So it's a great tool for a lot of reasons. And then we always end up talking about options. What do we do? Do we cut back our fertilizer a little bit? Do we increase it a little bit? Is this a trend that we're seeing that we need to, be a little more responsive to? Like Emily and Bob both pointed out, we really think that this is a very timely and efficient way to get this nutrient information back and help. From our perspective, so this past year in the spring of 2024, we ran a survey with our producers. So this Suwannee Valley that we're talking about comprises about 7 counties that are producing watermelons, total of about 8,000 acres in that area. We sent this survey out. We got 5,600 acres represented in response. So about 70% of the acres for this region were represented in the survey, which we felt like was a really great response rate. Again, farmers all speak a different language, but when you start asking them, how much has this enabled you to reduce your fertilizer application, specifically your nitrogen application, it gets kind of tough to get that dug out of them. How much less nitrogen are you using as a result of petiole sap testing? And it's tough. But what ends up working out, or a great way for them to look at it, is I've saved myself 3 injection cycles, or I've saved myself 2, but ultimately it comes back to where our average response was, we've saved about a week's worth of fertilizer application. Well, if you backtrack a little bit and do some math, and you went back to that plant growth curve that Bob showed with our fertilizer, I talk with my hands, even when I'm on Zoom, right? Anyhow, sorry, Aparna. Anyway, if you go back to Bob's plant growth curve and you look at the nitrogen application rates across that curve, if you average those out, it works out to about 1.75 pounds per acre per day. Well, if the average farmer that's using petiole sap tests recognizes that he saved himself a week's worth of injections, we can do some math and carry that on out. So if we look at those 5,600 acres that responded of what the benefits of petiole sap testing have been to them and extend that math to them, it's reduced the nitrogen application rates, well, and potassium in this area by almost 70,000 pounds, which is a dramatic impact in this area where we've got these very sensitive environmental resources. This is just kind of going over, we talk, this main purpose of this talk is to talk about petiole sap testing, but we thought we would kind of let you know about some of the other extension activities that we're doing with our producers. Bob takes lead on what we call the Suwannee Valley Watermelon Update, weekly watermelon update. He'll highlight diseases, he'll highlight environmental conditions, he'll highlight a lot of different things. The agents are able to enter in things they're seeing that might be going on if we have rindworm issues or whatever. It's just a great kind of resource. We're sending that out, and I don't know how your producers are, but if you've never used this Remind app, it's been around quite a while. School teachers use it to communicate with their students. My producers absolutely love getting the information in this text form. They can look at it on their phone when they're sitting in the tractor, sitting in the truck waiting for a crew to show up. It's just a great way for them to get information. I think right now on our Remind app, we probably have 180 producers or so in the area. that subscribe to that. And so they get this weekly watermelon update and they ask me questions. I have to make sure that I read it every week because they always have questions to ask me about it. Great tool. We already mentioned the weekly petiole sap testing available to them. That's like Emily said, that's a lot of agents across the whole area testing over 100 fields weekly. This rapid diagnostic services in the Suwannee Valley, we have a great relationship with some of our allied industry partners who have put money into a fund for us to be able to collect samples and take to the University of Florida for positive identification. A lot of the offices have labs where we can kind of look at things a little bit, but we really need that confirmation that we get from the lab. And for typically that's a $40 a sample test. And by this partnership with these allied industry folks, we're able to provide that for our growers free of charge. This irrigation flush calibration, I'll talk again a little bit about it more in a minute. But that's a service that the agents are offering to their farmers. The soil moisture sensor, I don't know what's available out in California. The sensors obviously are, but in Florida, we have a cost share program that's offered to the farmers through our water management districts, where the soil moisture, the cost of these sensors, there's about a 75% cost share. Maybe that's down this year. Anyhow, but there's a cost share opportunity for our farmers. So there's a lot of them that are taking advantage of this technology. They need a little help sometimes understanding some of the information that's available to them in it. And so the agents are providing that kind of support. Bob mentioned earlier the CRF, the Controlled Release Fertilizer Program. 2 years ago, 3 years ago, 2 years ago, we went on farm. So Bob had been doing quite a bit of work for quite a few years on controlled release fertilizer. As he mentioned, nitrogen is the big thing really challenging us in our area with our springs and our sandy leachable soils. Controlled release products are just a way to maybe reduce some of that nitrogen movement down through our soils into these springs. So we've gone on farm with some big projects over the last few years, and some of our farmers have actually picked it up on their own now. So we've got adoption we're super excited about. Paper mulch demonstrations, first time ever on a commercial farm. Last year we had 5 projects, Bob?
Yeah.
On farm using a paper mulch instead of a biodegradable or undegradable plastic mulch. This is a paper product with a biodegradable film on the back side. The beauty of it, one of our biggest pest weeds is nutsedge in this area, and it comes through plastic easier and it comes through soil, and it tends to be just a very limiting weed for us. It will not come through the paper mulch. So one of the projects we're working on, a lot of on-farm type work. We're usually hosting 1 to 2 field days and 1 big annual meeting annually, specifically targeting our watermelon growers. We do have several agents now working on automation. I don't know exactly how your systems run, but our farmers, we're on a 7-year rotation. So our irrigation systems tend to be pretty portable, and we've not really been able to automate until now. So we got some great work going on, a lot of adoption coming in with that. Bob talked about environmental regulations and challenges. Minimum flows and levels is recognizing that some of our waterways are below acceptable standard average levels, mean levels. And being in a very rural part of the state, ag is one of the bigger water users. So we're under a lot of scrutiny to try to become more efficient with our water use and recognize that we've got some challenges ahead. And then I'll mention just briefly a fertigation uniformity project that we're working on. Flush calibration, God, this was the simplest thing in the world. Just really easy to do, but I think probably more important than a lot of us recognize. In our drip irrigation systems, our farmers a lot of times will have a pump and an injection point that might be located either in the field or far away from the field, a remote location. They'll start their pumps up, irrigate. They'll inject their fertilizer, and then the question is, how long do I need to flush my system to ensure that I push fertilizer out of all the lines into the furthest point in the field? So we've started going in, pretty simple little deal. By the way, you can see how sandy our soils are, but you're trying to make me get done?
Not exactly, but I'll accept it if you do.
All right, I'll get done. The other thing we're doing is a fertigation uniformity project, just trying to look at system designs and are there ways, go ahead, you can click through. We're using EC meters, testing fertilizer movement in the field. Go ahead. I didn't know this was all animated, Bob. Sorry. Forgive me. Keep going. Just looking at different system designs, are there some that are more efficient than others? Ultimately, go to the next slide, what we're hoping to be able to provide, and it's animated too. Again, I'm sorry. Click, 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 click. Hopefully, eventually, we'll be able to provide some type of a heat map that we can show farmers where their fertilizer is ending up in their field and maybe be able to advise them a little bit on better system designs to make these systems more uniform in their delivery of the fertilizer. And I think that was my last slide.